If you recall, compound and inequalities can be very restrictive. In example 3, we can see a situation where we're almost too restrictive. We have an example where we say the set Barracuda such that Barracuda is greater than 11 and the set Barracuda such that every Barracuda has to be less than or equal to -5. We'll start with our number line. As we draw our number line, we'll put the 0 on there, of course. I'll go to 11. I'm not allowed to start on the number line. I have to do one statement above, one statement below, and see if there's overlap. In this situation, I would have an open circle, and this would shoot off to the right. I locate my -5. That would be a closed circle, and that shoots off to the left. Ultimately, as I go back through here, I'm looking for any place where there's overlap, where both statements exist at the same time. In this region, I only have the first statement, so that's no shading. There's no statements here, so there's definitely no shading. And then for the last segment, I have just a shading from that first statement. So as you look at the picture, there is no overlap. And if ultimately you're not going to have anything shaded on your number line, you would have to answer with the empty set. Meaning you were so restrictive, you had two conditions that could never occur at the same time, you would have the empty set. And if you think back about this, it actually makes a lot of sense. Can a number be bigger than 11 and smaller than -5 at the same time? That would be impossible. And since it's impossible, we ended up with our empty set. These two statements could not occur at the same time. As a student, you want to remember the difference between the OR shadings and the AND shadings. ORs, we go directly to the number line, we start shading without regard for anything. On the AND statements, we have to graph one above and then the other below and see if there's overlap. Only the regions that have overlap can be shaded. And so we'll quickly run through the first two examples again. You see how we had the two statements that were graphed. This was the overlap. This is what you expect most of the time. This is a pretty typical answer. Every once in a while, you'll graph your two statements and you'll figure that they're just leading off in one direction. So you get the one tail answer as we started with on this chapter. And finally, you get this situation where you have two statements and there is no overlap. This would be an empty set. Now there is one more idea that we have to present. So there's a fourth example coming up for the compound and inequalities.